Hi everyone in Algebra 2B. Today we're going to be going over questions on lesson 110B, starting on number 16. So on number 16, what I'm going to do is I'm going to multiply this equation by 35 to get rid of the fraction. And then the bottom, I'm going to multiply by 100 to get rid of the decimal number. So in the top one, I am going to end up with so 5 times 2, which is going to be 10x, minus 7y is going to be equal to 70. The bottom, I'm going to end up with 3x plus 7y is equal to 112. And now you should be able to see if I add those together, the y's are actually going to cancel. So I actually have 13x is equal to 182. So 182 divided by 13 gives us 14. So x is equal to 14. Now I have to plug that in, and I'm going to plug it into the bottom equation. So that would be 3 times 14 plus 7y is equal to 112. And 3 times 14 gives us 42. So I'm going to subtract 42. So I get 7y is equal to 112 minus 42 gives us 70. So therefore y is going to be equal to 10. So x is 14, y is 10. Now looking at number 17, what I'm going to do for the first one, well, what I need to do is I need to add the two equations together to eliminate one variable, then do the next two equations and eliminate a variable. And it actually makes it very easy for us because on this one, the z's would cancel. So when I add the equation together, I get 5x minus y is equal to 7. And when I add these two equations, the same thing happens, as these will cancel. So I get 7x minus 3y is equal to 5. Now you can do substitution or elimination on this one. What I would do, I would probably solve this top equation for y by moving the y to the right, moving the 7 to the left, which would make this 5x minus 7 is equal to y. Now you can do substitution, so that would be 7x minus 3 times 5x minus 7 equals 5. Distribution gives me 7x minus 15x plus 21 equals 5. Move the 21 over, and we get negative 8x is equal to negative 16, so x is equal to 2. Now that I know what x is equal to, I'm going to plug it into there. So that would be 5 times 2 minus 7 equals y. Well, 5 times 2 is 10. So 10 minus 7 equals y. So I know that y is going to be equal to 3. Then lastly, I need to solve for z, which you can do by plugging into any of the equations. I'm going to plug it into the top equation though. So I have 2 plus 3 plus z equals 1. 2 plus 3 is 5, so I'm going to subtract 5. So z is equal to negative 4. Okay. Now looking at number 18, what I'm going to do on this one, so I'm going to solve the bottom equation for y actually. So I'm going to move the y to the right and move the 1 to the left. So that'd be x minus 1 is equal to positive y. So now I have x squared plus x minus 1 squared is equal to 6. I have to multiply that out should be x squared minus 2x plus 1 minus 6 equals 0. And that would be 2x squared minus 2x minus 5 equals 0. And this time I'm going to do completing the square to solve. So I'm going to divide everything by 2 and move the 5 to the other side. So I get x squared minus x is equal to 5 over 2. Now if I take half of the 1 that's in the center, that's going to be x minus 1/2 squared. So I'm going to add 1/4 to both sides. So that gives me 11 over 4. Then I have to take the square root of both sides. So that would give me x minus 1/2 is equal to plus or minus the square root of 11 over 2. Therefore, x is going to be equal to positive 1/2 plus or minus the square root of 11 over 2. Now to solve for y, you're going to plug that into that equation. So it's going to be y is equal to 1/2 plus or minus the square root of 11 over 2 minus 1. So 1/2 minus 2 over 2 would just be negative 1 over 2 plus or minus root 11 over 2. So that will be x, and that's going to be y. Now moving on to number 19, what I'm going to do for this one, you just have to choose one variable to solve for. So you can just solve for this bottom equation for y would be equal to negative z. So I'm going to take that and I'm going to plug it into this equation. So that would be x plus 2 times negative z equals 5. So x minus 2z equals 5. And now what I need to do is I'm going to do substitution or elimination with this equation and this equation here. If you want to do substitution, you can solve this equation for x, which would be 3 plus z. And when I plug that in, it's going to be 3 plus z minus 2z equals 5. Move the 3 and add the z's, so that would be negative z is equal to 2. So therefore z is going to be equal to negative 2. Now that I know what z is equal to, I can solve for x, because x is equal to 3 plus negative 2, which means x is going to be equal to 1. And now I can solve for y, because y is equal to negative 2. So y is equal to 2. Now looking at number 20, I do have to graph. So for this first one, I'm just going to divide everything by 2 so that I have x is going to be greater than or equal to 3, which I know is going to be a solid line. This one is going to be y is less than negative x plus 3. So it's going to be a dotted line, and because it's less than, I'm going to shade everything below it. So let's start by shading or graphing the y is or x is greater than or equal to 3. So 3 on the x-axis is here. I'm just going to draw a solid line through there. Then the y is less than or equal to negative x plus 3. I'm going to go up 3. And then the slope is down 1 over 1. And this is a dotted line. And it should look like that. So now comes the shading process. So it says that we need to shade everything below the dotted line. So below would be everything down here. For the X, it's a little different because it tells us where we're gonna shade. If you put an arrow in the alligator's mouth, that points to the right. So that would be everything to the right of this line. Okay, so your answer is going to be that section that's going to be to the right of the solid line and under the dotted line. Now looking at number 21. So I squared is equal to -1. The square root of -9. Okay, so the top is going to become -2 minus 2i plus 2 over the 3i. And then square root of -3 times square root of -3 would just be -3. But because of this minus sign, it turns into +3. In the numerator, my 2's are actually going to cancel. So really, I just have -2i over 3i plus 3. I'm going to multiply top and bottom by 3i minus 3. You just need to flip one of the signs and distribute. So that would become -6i squared, which would be -6 times -1. And then -2 times -3 is going to be +6i over 3i times 3i would be 9 times -1. Then 3i times -3 would be -9i. 3 times 3i would be 9i. And then 3 times -3 would be -9. In my numerator, I have -6 times 6, which would be 6i. Oops, no, 6i plus 6. And then in my denominator, the 9i's cancel. I have -9 minus 9 would be -18. That's all divisible by 6, and I also want to move the minus sign up to the top, which would make this -1 minus I all over 3. So I move the minus signs up to the numerator, and then I simplified the whole thing by 6. Okay, so now what we're going to do is we are going to move on to number 22, where I actually need to simplify that square root first. So square root of 20 is actually the same thing as 2 root 5. So this would become 3 plus 4 root 5 over 1 minus root 5. Now to get rid of the square root, I'm going to multiply by 1 square root 5, 1 plus square root 5, and distribute. So 3 times 1 is going to be 3. 3 times root 5 is 3 root 5. 4 root 5 times 1 would be 4 root 5. And then 4 root 5 times 5 would be 4 times 5 over 1 times 1 is 1. 1 times root 5 is root 5. Negative root 5 times 1 would be negative root 5. And negative root 5 times root 5 would be -5. So the root 5's are going to cancel. Then I have 5 times 4 is 20 plus 3 would be 23. 3 root 5 plus 4 root 5 would be 7 root 5. Over 1 minus 5 would be -4. And we do want to get that negative to the numerator, so that would be -23 minus 7 root 5 over 4. Now moving on to number 23, we are going to start by distributing the 2 to the exponent and then also just moving everything up to the numerator. So this would be a to the 4 minus 2b, x to the 2, x to the negative b over 2, and a to the negative b over 2. Now I'm going to add the x exponents together and the a exponents, which would give me a to the 4th minus 2b minus b over 2, and then x to the 2 minus b over 2. Now I can't combine those, but I can combine the b's. So that would be negative 4b over 2 minus b would be a to the 4 minus 5b over 2, and then x to the 2 minus b over 2. And that is it for number 23. Now moving on to number 24. I'm going to change this from radical form into exponential form. So this would be 8. This would be 2 to the 1/2. And the whole thing would be to the power of 1/4. Now 8 I want to change so that it has a base of 2. And that would be 2 to the 3rd times 2 to the 1/2, all to the power of 1/4. And now I'm going to distribute that to the exponent. So that would be 2 to the 3/4 and 2 to the 1/8. Common denominator is 8. So I have 6 over 8 plus 1 over 8 would be 2 to the 7 over 8. Now looking at number 25, we need to eliminate the square roots from the denominator. So I'm going to multiply top and bottom by square root of 3, square root of 2. 24 would be 2 and 12, and then 2 and 6. So really for the first one, I'm going to have the square root of 6 over 3 minus 5 root 6 over 2 plus 6 root 6 over 1. The common denominator is going to be 6. So I have 2 root 6 minus 15 root 6 plus 36 root 6 all over 6. So I have 2 minus 15 plus 36 would give me 23 root 6 over 6. Now looking at number 26, we've already isolated one of our radicals. So all I'm going to do is I'm going to square both sides, which would give me k is equal to 6 plus the square root of k minus 48 times 6 plus square root k minus 48, which is going to get a little bit tricky. So the left side is just k. The right side would be 6 times 6, which is 36. And then 6 times root k, and then 6 times root k would just be 12 square root of k minus 48. And then square root of k times square root of k would just be plus k minus 48. So now the k's on both sides should cancel. I'm going to move this 12 to the other side, so that'll be negative 12 square root of k minus 48 is equal to 36 minus 48 would be negative 12. Now if you divide both sides by negative 12, you get square root of k minus 48 is equal to 1. Now square both sides so that you get k minus 48 is equal to 1. So therefore k is equal to 49. And now you need to check your answer by plugging it back into the beginning. So that would be the square root of 49 is equal to 6 plus the square root of 49 minus 48. Square root of 49 is 7. 49 minus 48 is just 1. And the square root of 1 is 1. So the left does equal the right. Your answer is k is equal to 49. Now moving on to number 27. If my r is positive, that means it goes to the right of the origin. And if my u is negative, it comes down off the x-axis. So that means my triangle is going to be in quadrant 4. 4 to the right, 15 down. Hypotenuse, angle. I'm going to use Pythagorean theorem to solve for the h. So h squared is going to be equal to 15 squared plus 4 squared. 15 squared is 225, so h squared equals 225 plus 16 equals 241. And I don't think that has a square root. The square root of 241, so we're just going to leave it like that. Then we're going to use inverse tangent to solve for the angle, and that's always opposite over adjacent, so that would be 15 over 4. So that would be 15 divided by 4 equals second tangent. So that means theta is equal to 75.07 degrees. And because it's in quadrant 4, we're going to subtract that from 360. So I get 284.93, but my answer will have square root of 241 for my hypotenuse on the outside, and my angle is going to be 284.93 degrees. That's number 27. Now for number 28. This is one of our factoring problems. So I need to start by writing this in descending order, where we're going to start off with 3s squared plus 11s plus 10 equals 0. Step number 1 is to multiply the first times the last term. So that would be 3 times 10, which is 30. Now I need two numbers that multiply to give me 30, but add up to give me 11. And that would be positive 6 and 5. That adds up to 11. So these are our two middle terms that are going to replace my 11s. And rewriting that problem, replacing the 11s would be 3s squared plus 6s plus 5s plus 10 equals 0. Now this will be your first parenthesis, this will be your second parenthesis. And you're looking for what's common in each parenthesis. Now within the first parenthesis, you see that both of those numbers are divisible by 3. Also that both terms have an s in it, so we can factor that out. And that would leave me with an s and a 2. My second parenthesis is a 5 that's within each parenthesis, so that would be s plus 2. And now it comes to the factoring. So factoring, you take out the s plus 2, and then your second parenthesis becomes what's left, which is the 3s plus 5. Now to solve, you have to set each of these equal to 0. So I have s plus 2 equals 0, and then 3s plus 5 equals 0. I'm going to move the 2 to the other side, move the 5 to the other side. So my first answer is s is equal to -2, and my second answer is -5/3. Okay, now for number 29, what you're going to look for is if there's anything that divides all three of those terms, and then write it in descending order. So for this one, all three of those terms are divisible by 2, and there's an x in each of them that I could factor out. So this would become 2x times 4x squared plus 3x minus 1 equals 0. Now you multiply the first term times the last term, so 4 times -1 is -4. Now I need two numbers that multiply to give me -4 but add up to give me 3. And actually, what is 4 minus 1? That's actually equal to +3. So I know that those factors are just 4 and -1 because they add up to 3. Now these are my two middle terms that are going to replace my 3x. So I have, I forgot my 2x, 4x squared plus 4x minus 1x minus 1 equals 0. First parenthesis, second parenthesis. Don't forget your 2x on the outside like I did. So now I notice that both of those are divisible by 4 and an x. So leaving me with x plus 1 in parentheses. Second one, I can factor out a -1, which would leave me with x plus 1. Now for step 5, we have 2x on the outside. My first parenthesis is going to be x plus 1. Second parenthesis is going to be 4x minus 1 equals 0. So we set all three of these equal to 0. First one would be 2x is equal to 0. Second one is going to be x plus 1 equals 0. And last one would be 4x minus 1 equals 0. So when I divide the first one by 2, it would be 0. Move the 1 to the other side, move the 1 to the other side. So I have three answers. I'm going to have x is equal to 0, x is equal to -1, and x is equal to 1/4. And lastly, looking at number 30, we have find h plus g of -2, where h of x is equal to x, the domain is reals, and then g of x is equal to x squared, where the domain is positive integers. So I have h plus g of -2 equals x plus x squared. Now if I have to check if -2 even fits within these domains. It is a real number, so that works. But is -2 a positive integer? Well, -2 isn't positive, so it is not a positive integer. And since it doesn't fit within that second term, you can't input this into the equation. So your answer is either the null set or the empty set. And your problem stops there. You can't input that into the equation. Now that should conclude all of your questions from lesson 110B. I hope you guys all have a great day. Bye.